In this video, we're going to learn about the graphs of the 6 trigonometric functions we've been learning about: sine, cosine, tangent. I've entitled this video the basic trigonometric graphs because all of them are just the trig function, y equals sine x, y equals cosine x, and so on. There's nothing else there. In later videos, we're going to see what happens if you have y equals, let's say, sine of 2x, or y equals 5 sine of x. And those will change the graphs. They'll make them look different. It's going to follow the rules of translations, reflections, stretching, compressing that you may have seen in other classes. But we have specific ways of doing that with trig functions to make it a little bit easier on us. This video is focusing on just the basic graphs, nothing more complicated than that. And so to get started on these graphs, we have to look at the unit circle. It's probably the most important concept in this whole class. And we're going to have this up in the right corner here just to help us remember what it says. It says that if you take a point on the unit circle and you have the angle theta there, the x-coordinate is cosine theta and the y-coordinate is sine theta. So if I want to draw the graph of sine x here, I'm starting at 0 because that's a normal way to start graphs. So 0 degrees or 0 radians is at that point right there, 1, 0. And as my angle increases, going from 0 degrees up to 90 degrees up here, which is the point 0, 1, the y value of these points starts at y value of 0 and gets all the way up to a y value of 1. And in fact, as you can see, that's the highest y value you ever have in the graph. So when I want to draw it over here, it starts at a y value of 0, and it's going to end up getting to a y value of 1. Just to make it look a little nicer, I'm going to go ahead and label this to be 1. And then on the x-axis, what angle that is, so that's when we get to 90 degrees, but we don't like drawing graphs using degrees on our x-axis. As I've mentioned in other videos, radians becomes the preferred way of measuring degrees or measuring angles for these types of problems. And so 90 degrees is the same thing as pi over 2. And so I'll go ahead and mark that right there. So the graph started at 0, goes up to 1. Then as we continue around the circle, the y value of 1 ends up going back to a y value of 0 here. By the time we get to 180 degrees is pi, so that's what we're going to have right there. Continuing around the circle, when we get to this 270 degrees, which is also 3 pi over 2 radians, we get a y value of -1. So it's going to look like this here. And that's also going to be the lowest my graph ever gets. And if we finish up this last part here from 3 pi over 2 to 2 pi, we get back to a y value of 0. So I can go ahead and mark this is 3 pi over 2, and this is 2 pi. And that graph gives us a graph of the sine function for one complete circle. The thing is, angles don't stop at just one complete circle. You could talk about going 2 complete circles, or 3 complete circles, or 4, or however many you want to. Or you can have negative angles going clockwise instead of counterclockwise. And so this graph is going to continue on in both directions. It would be a graph that would go on forever and it would be hard to draw. But the thing is, since we're just going around the circle over and over again, the y values are going to just keep repeating the same y values that you've already seen. And so this graph is just going to repeat, go from 0 to 1, go from 1 back to 0, and it would just continue on here if we had more space there. Similarly, on the left side, it's going to continue on in the same pattern here. And every one of these is at, so this is negative pi over 2 here, negative pi, negative 3 pi over 2, and so on. And so this then is our graph of our sine function. Before I draw the cosecant graph, I'll give it a minute here. Let's go to the cosine graph below it. because cosine is the exact same thing as sine. We're traveling around the circle, but instead of looking at the y-coordinate, we're going to look at the x-coordinate. So let's just look at that here. So as I start the point here, the x-coordinate starts at 1 and then goes down to 0. So cosine goes from 1x down to 0, then x is -1, then back to 0, then back to 1. And so my graph over here, it starts at 1, goes to 0, goes down to -1, goes from -1 back to 0, then back up to 1. And once again, same thing as the sine graph, it's going to keep repeating forever. And that repeating process, that's something that you may or may not have heard of in a previous class. That repeating process is called a period. Again, we're not focusing too much on the period in this video, but the period is the time it takes to repeat all the same values. And if you look at these two graphs here, oh, by the way, period, we also use capital T for period. And so the period for the sine graph and the cosine graph is going to be 2 pi, because that's how long it takes for it to repeat, which is 1 full circle. If I want to go ahead and label my graph a little better here, I would get these points, lowest values at -1, and so on. Now that I have sine and cosine, I'm going to do the graphs of cosecant and secant. The reason I'm doing them now is they are reciprocals of sine. They're reciprocals of sine and cosine. So since they are reciprocals, whenever you have a number on the sine graph, you're going to have the reciprocal of the number on the cosecant graph. So if you look at, for example, the time the sine graph is 1, you'd have the reciprocal of that over on the cosecant graph. Well, the reciprocal of 1 is also 1. Similarly, when you have a -1 on the sine graph, you're going to have a -1 on the cosecant graph, because the reciprocal of cosecant the reciprocal of -1 is also -1. And so if I were to fill in just these points here, where it's 1 and 1, it would look like this. Sorry, I just want to make sure I'm getting things properly here. So these are all the points where it's either 1 or -1 in the sine graph, because all of those, the reciprocals stay the same. And then a very important fact is, if the value of sine is 0, like right here, the y value is 0, if you try to take the reciprocal of that, that's undefined. And so every place that you have a y value of 0, your graph is not going to be defined. It's going to have what we call a vertical asymptote. And so I'm going to go ahead and draw these things here. And these vertical asymptotes are something very important that are going to happen on both cosecant and secant graphs, as well as the tangent cotangent later. And then to finish filling in the graphs, if you take a small number, let's say like a half, and you reciprocal it, you're going to get 2. And so what ends up happening is small numbers become big numbers, and the end result gives you a graph that looks like this for cosecant. And we can do the same type of thing on cosine. Let's look for the places that cosine is 0. And let's go ahead and put our vertical asymptotes at those places. Everyone here, and then a couple more to go. And then we look at the points where they're either 1 or -1. And we're going to mark those same points over here. This is kind of the easiest way to draw these graphs, is to draw your vertical asymptotes, draw your +1 and -1 points. And then you fill in, they look like parabolas here, or upside down parabolas. This one you only get to see half of it in the picture. And so you can see your cosecant and secant graphs are very similar, just like the sine and cosine are very similar. They're just kind of a different place you're starting at in the graph. They kind of shift it around a little bit. The last two graphs are a little bit harder to deal with, tangent and cotangent, because it's not the x-axis, it's not the y-axis, it's actually the fraction, the y value over the x value on the unit circle up here. Right? If I wanted to find tangent, I would take the y value, divide by the x value. So it's harder to see that. However, if we look at tangent, it's going to start at 0 because it's 0 divided by 1. And then by the time you get to pi over 2 here, your y value is 1, but your x value is 0. That means you're trying to divide by 0, you're going to get a vertical asymptote. And basically gets bigger and bigger and bigger. On the left side, it goes down here. And then if I continue this process around the circle, I'm not doing all the work here. We're just trying to get the basic graphs down so you can see them. And this time it's going to repeat them in this way. It's just the same shape here over and over again. Kind of like looks like y equals x cubed, but it's not the same. And one thing important to note here is that the actual period, since it repeats the same up shape twice as fast as the other ones, the period is actually just 1 pi instead of 2 pi. Finally, for doing cotangent, it's the, again, reciprocal of all of that. So that means the places where it was 0 on tangent, those are where the new vertical asymptotes are going to be. So we'll go ahead and put the vertical asymptotes here. And then the graphs here, when you get to say pi over 2, that's when you'd have 0. And so let's see what we're looking at here. When you're between 0 and pi over 2, it's going to be really high values here, then go down. So the graph of cotangent, again, kind of similar in concept to the tangent graph, but flipped in a sense. And finally, this is your quick rundown of the 6 basic trigonometric graphs. As I said, we're going to have future videos where we take these and do the more complicated versions of them. So at this point in time, you just want to try to understand these 6 graphs, be able to draw these from memory before we go on to the more complicated ones.